What's up, guys? This is Brock, Brock's Off-Road Recovery, and this truck is really stuck. So I'm gonna go ahead, hook up my winch. I got my winch power on. Just gonna pull it out a little bit. Just gonna go ahead, hook up one of the few tow points that's in the front of the car. You can see there's two of them. One there and one there. Unfortunately, there wasn't any in the back just to be a better tow spot, but I don't know, this works too. Alright, so I'm about to hook it up. Just gonna clip it on. It's on. Now, let me go back to my winch, engage it. Now let me go take up the slack. Alright guys, so I got my winch engaged, I got it hooked up. I'm gonna go ahead and take up the slack a little bit. That's good for now. And then, yes, you have a question?
I do have a question. Does the car have to be in neutral or anything?
I mean, yeah, it does have to be in neutral. You could either have it be in neutral, or Wade, what I might have you do is I'll have you just in the car in drive, and then you can give it a little bit of gas as I'm pulling you out, and then you just watch the brakes, just stay on the brakes. But I need the shirt because in case the rope snaps, it's kind of dangerous. So if it snaps and that, it's kind of, it doesn't hit you. All right guys, all right, Wade, you ready? All right, just give it a little bit of gas. You can start going. Oh wait, yeah. Start going. There you go. All right, now stop. All right, so we got them unstuck. Mission success. Now I'm gonna go ahead, just detach my winch, roll it back up, and then I'm good to head home. All right guys, so I'm back after the recovery, and now I'm gonna dive into the science and physics behind it. If you're interested in that, stick around. If you're not, you're free to go. All right guys, so I have my paper here. This is, this is my paper. And I want to start off by just showing this little diagram down here of kind of what happened. So what happened was the driver was driving, he got stuck, he continued to press the accelerator, and then he kind of dug himself into these little holes here. You can kind of see I did a little divot there. Just got the axle and the tires. So now going up to all of this stuff, I mean, it might look a bit daunting, but we'll break it down. Okay, so you have the truck here in this little picture. This was the trail. It's very simple, but you got the trail. You have this whole equation, F equals ma, which is the equation for force. And force is a vector. So you need to have a positive and negative direction, which is why I did a little plus and a minus. It doesn't really matter how you notate it. I just did it that way. And you have force applied from the truck and force applied from, we'll call it friction, because that's essentially what it is. Okay, so now you might be looking at this equation over here and you're like, okay, Brock, what the heck does that mean? So essentially what this is saying is the force that's being applied from the car is being canceled out by the friction. And the reason why it cancels out and it equals 0 is because say the mass is like 5 pounds, right? It's not. Obviously a truck weighs more than 5 pounds. I know that. But say it equals 5 pounds. And if these two cancel out, then the acceleration has to be 0. Because if this is 0, 0 times 5, it's got to equal 0, right? So all this is saying is that it's canceling out. And therefore, if it's canceling out, then the truck isn't going to move, right? It's the same principle as if I have this pen here and I'm pulling on it with equal force from each side, but then this side over here pulls on it with more force, it's going to move in that direction. That's the whole principle with how I got this car free and why it got stuck. Okay, so now this diagram is after I hooked up my winch. So the winch is in blue there. Right there, you still got the positive direction, negative direction. It's still a truck, I know. But this time, when it starts to move, That's because the sum of these two vectors, right, you add up the magnitude of the vectors right here, and then you subtract the friction, right, because F equals ma, sum of the forces, sorry, I probably should have mentioned that earlier, but sum of the forces is equal to mass times acceleration. So you got this sum of the forces minus this friction is equal to the mass times acceleration. So these two are going to overcome this friction force, which is going to cause this mass to accelerate in that direction. All right, guys, I hope you enjoyed that little demonstration. And remember, if you ever need help, call Brock's Off-Road Recovery. I'll get you free.